So here's try to help you understand what does it mean to reject the null hypothesis. So we've got some pennies. We know pennies are supposed to have an average weight of 2.5 grams. They went out and did 30 random pennies, and the average of those 30 pennies was that standard deviation. So because we don't know the parent standard deviation, population standard deviation, and we don't we can't use z-scores, because now we don't know if the weights of pennies are normally distributed, but because we've got a sample of 30, we're okay. We can use a t-test. You could either have a normal parent population or your sample has to be 30 or larger to use a t-test. So if it wasn't one of those, we'd have to use a different technique. So we're going to do a significance test. They're telling us to do a significance test. So the hypotheses that I tested were right here. I said, yeah, this pennies do actually weigh on average 2.5 grams, and this one sample is just a fluke. We could go out and do a sample of another 30 pennies and find a similar, and have averages equal to 2.5 or just a little bit more than 2.5, and that's why I went with a two-tailed test, because I don't know if it's greater than or less than, but I just want to know that it's different from. Okay, so then you can do the test statistic, and I let the software do that, and I came up with a t-score of negative 0.3. So now maybe we should look at this using critical values. So what we need to figure out is what's the critical value for this test statistic, and because it's two-tailed either side, so I've got 29 degrees of freedom, because remember it's n minus 1. So and they're telling me at the 5% level of significance. So because I've got a two-tailed test, I want to have those two-tailed areas add up to 0.05. So I'm going to use this column, and I got to come down this column until I find 29, because that's my degrees of freedom. So there's 29, so 2.045. So negative 2.045 and positive 2.045. Okay, so now any place in here, in between those numbers, is the happy place for HO. That says that we can't reject HO. It's perfectly, it's just anything in that range is just due to any time we get a sample with an average in that range, it's just due to random sampling error, and we can't say that we can't reject HO, say that the average is not equal to 2.5. So if we compare that z-score or t-score we got, that t-score is inside that range. It isn't in the rejection region, so we say. So it's in the happy place for HO. So we can't reject HO, which means it looks like the pennies do appear to conform to U.S. Mint specifications. And this one batch of 30 was just a fluke, within acceptable limits. Now another way to have done this is to talk about the p-value. Now, because it's a two-tailed test, okay, because we had to talk about the area in two tails, and that area in both those tails adds up, according to the software, to 0.67 or 0.76. Now, we only reject HO as if this p-value is less than the level of significance, and it certainly isn't less than the level of significance. In fact, it's far, far greater. Another way to think about the p-value is this is the probability that we're wrong if we reject HA or reject HO, and that's a very large probability of being wrong. So we would not reject HO. that would mean the same conclusion as we got before, that the pennies do conform to the specifications. Okay, so you can either look at critical values of t or look at the p-values. My preferred method is the p-value, especially since the software tells us that. Okay, let's try another one. So this deals with testing child seats, booster seats, and the safety requirement is that, let's see, whatever this unit is, it should be less than 1,000 of them. So we've got some data. They're telling us that this is coming from a normally distributed population. So even though we can't use a z-test because we don't know the population standard deviation, it's safe to use a t-test because even though we've only got 6 pieces of data, we know the parent population is normally distributed. So we've met that condition. If that hadn't been the case, then we would have had to use a different technique, one that we're not going to study this term. But we're good. We're good to go with this t-test, and they give us a level of significance. So we want to test the claim that the sample is from a population with a mean less than 1,000. So in other words, are these meeting the requirements? So I guess our null hypothesis is going to be that they don't meet the requirements, that it's equal to 1,000 or more. That the unit, and then the test will be is that nope, yeah, they're okay. They have less than 1,000. Their average is less than 1,000. Okay, and we could calculate the t-test. We need to find a standard deviation and a mean for the sample data and run it through the test. We can also use that StatCrunch or that Rossmann Chance applet to do this, and I chose to use the Rossmann Chance applet. So this applet let me use data. I didn't have to go out separately and calculate the mean and standard deviation. What you got to do to use this for that is make sure you check the paste data, and then if you can copy and paste it, great. Otherwise, I just typed in those 6 numbers. Okay, then I clicked use data. That would have given me this and this and this. Then I got to set up my test. Well, there's my HO. I had to select one mean, of course. It set up HO and then say that it was less than 1,000 for HA. And then I let it calculate the t-score and the p-value. Okay, and if we just go with a straight p-value connection, which is easy, so we got a 0.0224 for a p-value. We've got a 0.05 for a significance level. This number is smaller than that number. Now what that tells me is this is the chance that I'm wrong if I reject HO. And the level of significance is the acceptable level of risk. So this says as long as you have less than a 5% chance of being wrong, you should reject HO. Well, we do. So we can reject HO, which means yes, it looks like these seats come from a population with an average less than 1,000. Okay, now if we wanted to do this with the critical values of t, let me get that table. So to draw this rejection region, now we just have a one-tailed test. It's a left-tailed test. We're going to look for that cutoff. And this is the happy place for HO. It won't be rejected if it's in that range. So what we're going to do is we're going to look at the area and one tail. So because we've got a one-tailed test, we're going to concentrate all that area into one tail and use this column. And we've got 6 pieces of data, so we have 5 degrees of freedom. So there's the value we're going to use, the 2.015. Only it's going to be negative, right? Negative 2.015. And this is going to be our rejection region. If HO gets rejected, if our t-score is that small. So let's see, what was the t-score? The t-score was right here. That's the test statistic. Since negative 2.66 is less than 2.015, it falls in the rejection region. We have to reject HO, which is the same decision we made with our p-value, right? Should be the same. So again, same decision, just looking at it from a different viewpoint. Okay, hope this helps you decide about rejecting or when not to reject HO.